Swayam Prabha. Digital India. Educated India.
Hello and welcome back. I am Dr. Abhinav Dhal from the Indian Institute of Technology, Ropar, and I will be discussing today the applications of affective computing. Friends, this is in the series of the affective computing course which we are conducting on NPTEL. So in the last lecture, we defined affective computing, and then we looked at the various modalities which enable the content to be captured, can be from a camera, from a microphone, from a text perspective, and then how we can have a computational model which can predict the effect, which tells us about the emotional state of a user or a group of users. So the agenda for today is discussing about the applications, and later on we will be talking about the different areas in which emotion recognition, affective computing is applied. So with respective of applications, what we can do on principle is we can have a system which can detect the emotion of the user, and then in this pursuit the system would also express the appropriate emotion which is in response to what has been detected. So the first step, as we discussed in the last lecture, is affect sensing. The machine understands the emotional state of the user, and the second is to express appropriately, which is a reply to the understanding which the machine had about the user. Now when we are expressing, we are talking about, let's say, an avatar or a robo or an animated conversational agent which would try to show facial expressions or would try to have the variation in the speech which would then give a perception of an emotion which is there in the speech. An example of that could be, let's say if I was a digital avatar, then if I was to greet a user, option 1 could be, I could say hello and welcome. Now this is very neutral. The other could be, let's say I want to give a cheerful greeting, so I will say hello and welcome. So this now has a emotion which is more towards the positive side, more towards the happy side, which is indicated by my speech, right? So this is on the generation part, the synthesis part of the emotion. Now we would like to actually create these systems which can perceive the emotion, right? So this again is part of the affect sensing step in the affective computing. So now let's look at first the perception, the detection aspect. So if we talk about the healthcare and well-being domain, there are a large number of applications where affective computing is highly relevant. An example is this project being done at IIT Delhi by Dr. Janendra Shukla's lab, which is called Visharanti. Now the aim of the project is using the sensors in a watch, in a smartwatch, we would like to predict if the user is stressed or not. So essentially with the sensors which are there in my watch, we would be capturing the user data. Then we would be using a classifier. Now this classifier would either tell us if the user is not stressed or if the user is stressed. Now if the user is stressed, then there is a recommender system which would recommend an activity, and then there is a loop forward and backward which runs between the user, the recommendation which has happened, and it can be added to the classifier as well. So what it means is we are learning online the user behavior, and then we are trying to personalize the model so that it can predict not just the stressed or non-stressed state of the user, but also give appropriate recommendations when the classifier predicts that the user is stressed. Now in the same direction, there is another very important application. So typically patients who are suffering from Asperger syndrome or are high functioning autism. So, they are on the ASD spectrum. So, there would be record keeping which is done, let's say, by a parent for their child who is on ASD, could be prescribed by the doctor. Now, in that there are several questions. For example, how was the child behaving at a particular instance in time? Or was the child agitated? Was the child relaxed? Now, the answer to all these questions is based on the subjective interpretation of the child's state from the perspective of the parent. So, the parent would input into the app if, let's say, the child seems to be relaxed or not. Now, this subjectivity and the continuous record keeping which is required is actually time consuming, can be noisy because there is possibility of confirmation bias coming into the picture. To this end, we can use affective computing and behavior analysis to automatically detect the state of the patient. For example, if the patient is looking relaxed or stressed. Now, this can be based on the visual cues, the expressions and all, or it can be on the basis of speech. And we can then use these apps which can automatically do the record keeping for us, and over the time this longitudinal data would be a very rich analytics which can be then presented to an expert or doctor, and that can help in let's say better diagnosis or treatment. Now, another important aspect of the role of affective computing in healthcare is in the case of PTSD, which is the post traumatic stress disorder. So, a typical example of this is soldiers who have been to war or similar difficult circumstances. So, when they come back, the effect of the happenings in that war or similar circumstances that may lead in a few cases to PTSD, right. So, using affective computing, we can detect the changes which have happened in a person, which is reflected in the way in which they are communicating based on the body gestures, speech and facial expressions. And this information can then be used by an expert to give suggestions, treatment to a particular patient. For example, here what we see is an app called StatalMart. It's a platform which has these virtual environments, right. So, these kind of treatments can be used wherein both the stimuli can be used for generating elicit an effect in the person, and also remedies can be given. Another example from the Rochester HCI group is these interviewers who are interviewing this refugee. If you notice, there is an EEG headset, a physiological sensor. So, as the interviewers ask question to the interviewee, the response which is given by the interviewee and their perception of the questions, the discussion which is going on, it does affect how they are feeling, and then that is recorded as part of the EEG data which is captured by the EEG sensor. So, later post analysis can be done and we can find out different attributes about the affective state which tells us about how that person is feeling and is extremely helpful in looking into how their mental and physical health is, which of course, for example, in this case of a refugee would be an important information in, let's say, their rehabilitation and how they are actually getting absorbed into the new society. Now, changing the gears, friends, there are other of course, health and well-being applications of affective computing. Now, let us move to the educational applications. So, in 2014, Danal and others proposed Engage Me. Now, what Engage Me is? This is a system which is using a physiological sensor which is measuring the skin conductance, and along with the video feed, it is capturing how the student are in a classroom, such that we can collate the overall engagement and affect for the teacher to later reflect on. Now, if you see, when you are looking at the skin conductance data, of course, there is a sensor which is on the, let's say, the arm of the student, and then there is a camera in the classroom as well. So, together the data from this can be combined to do rich analytics. Of course, when you are talking about video feeds, you have to be super careful about the implications of the identity of the person, and also if the data which we are capturing about the user, it is not in any way releasing or leaking the identity information about the user. Now, on the same lines as Engage Me, there is another work called Subtle Stone. So, it was proposed before Engage Me by Balam and others in 2009. Now, this is fairly interesting. Now, what Balam and others proposed was a wireless handheld squeezable ball, which allows students to communicate their affective and motivational experiences to the teacher in real time. So, now this is you can say a wearable object, and based on how the feedback to this squeezable ball is, that can be used as an indicator, a way of communication, and we can use that as rich analytics based on the affective state. Now, here is an example of student engagement and learning effectiveness measurement using facial expression cues. Now, this demo is from the Machine Perception Laboratory at the University of California at San Diego. And what is happening here is that this is the tutor, here is the student, and they are interacting, asking about some maths questions, and the student is telling about the complexity of some of the questions, and while they solve, their facial cues are being analyzed for different expression categories, and that is used to map to the self-reported complexity of a question which the student felt. Now, let us look at the video.
To face the mat.
This is a research project at the Machine Perception Laboratory of UC San Diego on using automatic facial expression recognition to improve interactions between students and teachers. In one particular project, we are measuring the facial muscle movements of the student in real time using a face detector and an expression recognition.
Now, here is the rich analytics, which is essentially given from a smile detector, and then the movement of the head, which of course then shows you engagement and so forth. Now, when this information is collated, you see the difficulty versus time, and how the self-reported difficulty and predicted difficulty, they are actually having a correlation. Now, what it means is you can use the facial expressions, head pose cues, and then apply it to better learning environments to assess if we have effective learning in a classroom environment, and in today's context in online environment as well. Now, let us say if it was an online learning scenario, then one could predict the engagement in the form of the facial expressions, eye gaze. Now, friends, eye gaze is the location onto which your pupil are fixating, right. So, where are you looking at this point, okay? And using head pose, gaze, you can actually learn a classifier which can predict the engagement intensity, okay. Now, as you can see in this example here, here is the timeline of this educational video which is being studied by the students. This is an online material, and what we see is, for example, and at this points the engagement is fairly high. Here you see that there is a dip, and in this case the person actually is looking downwards and not at the screen, right. So, we can do this fine-grained analytics and then see what is the engagement level of a person when they are consuming, when they are viewing this material. Now, one can go a step ahead, right? So, you can quantify engagement, and you can say, for example, you could have a low level where the person is not paying attention. You can tell them from their head pose and their gaze, and let's say the facial expression as well. And the other is high, where the person is really fixating on the task. You can imagine this also from the perspective of the car driving monitoring as well, if the driver is paying attention. Now, here is an example I am going to show you from human-robo interaction perspective. There are two parts. The first, of course, is the sensing part. Now, what is going to happen in the video is that there is a robo, and that robo is speaking about a life experience. Now, this life experience is borrowed from a popular TED talk. In the field of view of the robo, there are users. So, let us say these are the users. Now, based on the head pose, that is the location and the angle of the frontal part of the face with respect to the view of the robo judges the engagement of the group. Now, if the engagement goes up, the robo maintains its pitch and volume. If it goes down, then the robo adds variation. Now, this is the sensing part, and the response of modulating, that is the reflection on the basis of what we sensed. Now, what is also going to happen is that the gesture of the robo are based on the text which it converts to speech. So, what the robo is speaking, the gestures are also generated accordingly. So, let us play the video here.
She refused to sign the final adoption paper, relented a few months later when my parents promised that I would go to college. This was the start in my life.
Now, there are some interesting points which come into the picture. One is, let us say there is a communication happening between an agent or a robo to a user, right. So, it could be either an agent or a robo talking to a user. Now, how does the agent or the robo realize that the conversation is ending? The other question is, what is the appropriate behavior of the robo or the agent once they have predicted the affective state of the user? A simple example can be, let us say there is a robo, a social robo in a house. The user walks into the living room and is visibly distressed. The robo, using the camera, locates the face of the user, analyzes the facial expression, and if the robo is able to sense that the person is distressed, then they can, for example, maybe crack a joke or can ask questions or give relevant information which can help the user to feel better. Now, on similar lines, one could also use affective computing and the analysis of the face and speech in training. Okay. So, here is an example of the My Automated Conversation Coach, the MARC system, which was developed by Sanak and his team at the MIT Media Lab. Now, in this case, there is a virtual agent and there is the user. So, they have a conversation, and in this lieu, during this there is a camera, and the camera captures the face of the user, and in this it will look at things such as sense of smile, the head pose, gaze, and so forth. And then the user at the end of the conversation can get very rich analytics about how they were perceived based on their expression or head pose, and they can use this to train themselves, let's say, to speak better. An example could be during an interview process. So you can prepare yourself to speak better in an interview process. So let's see the video. Now this is a video which is available on YouTube. Now here is another example. Now this is a robo named Kismet, which was developed in the late 1990s at the MIT Media Lab. Now what the robo does is, it senses the person's facial expression and then will try to mimic it, and it will, let's say, try to give a big smile if you showed a big smile in front of the robo. So the aim is quite simple. You sense the affect and then you react accordingly. Now here is a video of the robo.
In 1997, Professor Brooks and his team built Kismet, a small robot with eyes, ears and a mouth so it could see, hear and experience the world around it.
Look at my smile. Oh, that was cute.
Now moving to a smart interface. So this is an example from Monash University wherein they proposed a mirror ritual system. What it does is, it looks at the emotional state of the user through a camera, and then it would generate this text, could be a poem, which is better mapped to the emotional state of the person, right? So they propose this as an emotional self-reflection tool. So there is a mirror, there's a camera, you come in front of it, it senses your emotion, and then it will generate this poem which is based on the emotional content, which is a reflection of how the user is feeling based on their facial expressions and so forth. So again, in this we see the sensing part and the response part. In the response, here is the text which is generated by the mirror. So here is the video.
Mirror Ritual is an interactive artwork that challenges the existing paradigms in our understanding of human emotion and machine perception. Through AI-generated poetry, the mirror speaks to the viewer, each poem unique and tailored to their machine-perceived emotional state. Mirror Ritual augments the human experience of emotion, expanding it beyond the internal, unreflected experience into the realm of the tangible and expressible.
Now friends, we see all these applications, right? In healthcare it is there, in education domain it is there, we have it in driving as well. In fact, now there are games coming up. Now in these games, one of the expectation from the user is to show, let's say, a particular facial expression. So let's say we have this game which is designed, created to help a patient learn to express better, to show facial expressions better. So in that case, the task would be to show facial expressions on the user's face, and then there is a system which is trying to predict that if, let's say, the smile was a high intensity smile, right, only then the person moves to the next level. So there is a gamification as well. So in this as well, the facial expressions and the affective cues are being used. Now, for such interfaces, where you go to the next level in a game, when you show a certain facial expression, these are now emotionally aware or emotion aware interfaces. So the pursuit again is now on the lines of creating these smart interfaces which are aware of the emotional state of the user, so that the content which is shared to the user is in sync with how the user is feeling, and let's say not to overwhelm the user with information which can have any adverse effect. Now, in the pursuit of creating these interfaces, there is the whole domain of UX, the user experience, how the user will be experiencing when they are interacting with the interface. And there is a whole line of study in this user experience, how we can get the requirements, how we can then test the requirements, right? I'll briefly touch upon this, and then I will discuss on how we can use, for example, an affective computing based technique to expedite and to know the user requirements and the user response better when you're talking about the user experience. Okay, so let's formally introduce user experience. So UX, now it's a very broad area. It encompasses many aspects of a user's interaction with, let's say, a product. You could be designing a website, and the organization. Okay, so it's typically saying you create a website, and now you would like to understand, before releasing it to the masses, how do the users in a control group feel about that website. Now, in this context, usability is more the practical side of the things. So the question is, how much easy it is, let's say, for a user to achieve a certain goal through this website or this product which you are creating, and in that pursuit of achieving that goal, how easy or how easy interpretable the information which was presented to the user was. Now, the combination of these two would lead to a better understanding of the emotional experience and interaction with a brand, and hopefully add to a memorable positive experience. An example of that is, let's say we are creating a website for old age users. Okay, now when this old age user goes online, goes to this website, and let's say they are supposed to find certain information. Okay, now how easy is it for them to fetch that information, and how can the system recognize that if a person is now struggling to find that information? Once it recognizes this, let's say, confusion state, then how can the system react, right? How can the information be better presented? For example, if you don't find that information, maybe trying to increase the font of the certain part of the page on your website. Now, in this whole process, before, let's say, you make your website live, how are you going to test it, right? How would you actually know that the experience is good, it's easy to use, and the purpose is also achieved, right? The purpose of, let's say, why you are creating a website in the first place. So a traditional approach would be to do this participation design. So a typical approach here would be to do participated design, accept and test. Where you have these control group stakeholders who would be involved in the design, right? So from the website, for elderly example, you could actually have a few elderly users, and you could fetch the information from them, that how they anticipate, how they expect the website to be, right? Now, this will give you idea about the aspects of the user-centered design. This is what the user wants, right? And then once you know what the user wants, you can actually have the website designed accordingly. Now, there are different approaches. From 91, from Mueller, the Affective approach. And then once you have done this, you have the acceptance testing as well, right? Now, you would like to test the product, and you want to understand the functionality, usability, reliability, and compatibility. Now, from our example of the website for the elderly, how correctly the website is functioning, how is the user reacting, and what is the feedback from the user. Now, this feedback from the user is typically done in the form of self-reporting. You could actually, let's say, give a form to the user and then have a series of questions which would be validating, let's say, your design hypothesis and your design philosophy, and are the goals of the product, let's say the website example which I shared with you, are those goals served or not. Now, there are some issues when you're talking about these self labeled or these surveys which are performed. The first is it's non-trivial sometimes for the users to articulate very clearly how they are feeling about or what is their experience with the product. And typically what is observed is that these are affected by things such as the participation bias. N number of people are already saying this is a good product. I'm not so sure, but well, because N people are saying, oh, I'll also say yes, this is a good product, right? And then also based on our prior experiences, history, how the prior memory, our memory is going to affect our judgment of the current product during this testing phase. Now, let's say we take an example of this website, and this is about marketing, okay? So and videos. So these videos which you want to show onto this website, which is for elderly users. So what we can do is we can use affective computing now here. Now you see how affective computing is going to come into the picture. We understood the user requirement, we created the website, and now we want to understand how the user feedback is. Okay, are our objectives met or not? If they are not met, then we would like to go back, rehash and improve the site, improve the product, and before releasing it to a wider audience. So what we can do when the people in our control group, the participants, they are exploring the product, the website in this case, we can then have them being analyzed using a system which is going to look at the different aspects such as expressions and head pose and so forth, okay, if we are using a camera. And once you have this information, you can then make a decision about how the changes should be or how the product is actually turning out. So let's see what we can do in this case. So you can we are taking this example of a web-based interface for the website, and some main considerations when you are going to create this kind of website or user interface, usability testing with affective computing is how are you going to have this control group, what are the type of sensors which you are going to use, are you going to have a large number of users who are going to be evaluated, and how comfortable these users are, let's say, to be analyzed through a camera, or how comfortable are these users when you put a physiological sensor on them, right? So here is an example. So this user is participating in a study. Let's say there is the website which the user is browsing. Now here we have the EEG headset. We also have a camera. So you can now analyze the, let's say, the action units, the facial expressions, and along with the EEG signals, you can use it to understand how was the user behavior when they were doing a certain task on the website. Okay. So this can give you very valuable information, and when you're going to collate it over a large number of subjects, you can then find out, similar to that engagement example. Okay, so when the user, let's say, is trying to search for information, that is where they, let's say, lose interest, because it's non-trivial to find information on the website. This is an example. Now, while we are discussing all these applications, it's important to explore the ethical considerations, right? We talked about health related applications, education related applications, right? Now, particularly for health and well-being, we might be dealing with a patient. So, it is extremely important to be observant of the following. When the user is prompted that, okay, you may take a break because the system sensed that you are a bit stressed. The system sensed that the user is stressed. Now, there are these ethical boundaries here, okay. Is the user aware that the system is analyzing the user? Is let us say recording their physiological sensors, or is analyzing the speech or vision? So, has the user approved for this? And once the user, let us say, has approved, the system analyzes for stress, or let us say the facial expression which are going to link to the emotion, and gives a recommendation. Then is the system trying to manipulate the user? So, what is that fine line, what is that boundary which we can allow for the system to recommend a user about something, okay. So, what this means is, it is not about just computer scientists who are going to come and create a system, but we also need experts from social sciences about what is going to be the user behavior, how the user ideally should react, and how the system should present the information. The other super important aspect is privacy. Quoting from Professor Rosanne Picard, emotions perhaps more so than thoughts are ultimately personal and private, right? How you feel, it's a very private thing. And to analyze the emotion of a person or a user through facial expressions or speech, or through other modalities, could be invading into their privacy. So, what it means is, we have to be mindful of the user identity and personal information being hidden. An example of that is, let us say a system was being created for analyzing the effect of adding certain new feature in an app which is used by children, and for analyzing the effect of adding that feature, the developers use facial expressions. Now, when you analyze the facial expression of this subject, you have to make sure that you only share or record the facial expression, but not the identity or the personal information. And that facial expression can simply be saying, for example, at timestamp T1, subject 1 was showing a neutral expression. What could be invading into privacy is, you could say at timestamp T1, subject 1 name showed neutral expression, right? You do not want to divulge the identity, and right. And also, what are the scenarios where you are going to use this information? So, let us say if we have a system which is used to online assess an interview candidate, and the candidate is shown to be visibly stressed, the system detects that the person is stressed. Now, maybe that person is stressed due to something which is outside the scope of that interview, okay. Should that be communicated to the interviewer or anyone who is going to analyze the video later on? So, we have to be very mindful in effective computing about the privacy aspects of the user. Now, the third ethical consideration is emotional dependency. Could having users routinely use these moral agents create codependence? Checking your expression, or getting analyzed your speech pattern, and then getting this feedback from the system that, okay, please, let's say, take a break, or you're doing very well. So which the user gets too used to this, is too dependent on this kind of information. So this means when designing such application and system which use affective computing, we need to bring into experts from interaction perspective as well, that what is that point after which the user could get too dependent, right? Could like to get the feedback from the system so as to do simpler tasks. Now, the designer could have started, the designer of system could have started with a noble aim that we would measure, let's say, the expression or the emotion, and then we will recommend something, or will show some analytics. But on the other side, we see that the user gets too dependent on it. So what is that fine line? And of course, then that means this is actually based on how the system was designed, what was the intention of the system, and how well it was tested before that affective computing enabled system is released to a mass audience. So friends, with this we reach towards the end of the application part of the fundamentals of affective computing lecture. We discussed about the different applications of affective computing, focusing on healthcare and well-being, moving on to the applications in the education sector, online tutoring, and then we saw examples of human-robot interaction and interfaces as well. Later on, we moved on to how we can have objective feedback in the form of the emotions, which can be used in, let's say, an example like neuromarketing or creation of a product, where you would like to understand the user feedback, right, from the perspective of user experience and so forth. Thank you.